Hi all. So today we are going to discuss the topic linear growth and linear decay. So after knowing what is linear growth and linear decay, we will move to the exercise questions. Okay. So without wasting time, we will start with what is linear growth. For that, we will start with a problem. So example 9 says that the cost of a journey is given by the linear function c of d equal to 100 plus 60d, where c indicate the total cost in rupees and the distance traveled in kilometer. Let us make a table values for d varying from 0 to 10 as show how the cost increases for every kilometer. Okay, so distance traveled is first of all given as 0, 1, 2, 3, 4, 5, etc. Right? So you know in the initially they have 100 rupees with them. For every kilometer they travels 60 rupees add on, right? So initially they have this 100 rupees for first kilometer. 100 plus 16 into 1, that is 160. Next one 100 plus 2 into 60, that is 100 plus 120, that is 220. It goes on like this, right? Third kilometer it will be 280, fourth kilometer it will be 340, fifth kilometer it will be 400. It goes like this. So last class we have learned how we will write the nth term like this, right? If you goes like this, what is the nth term? What will be the nth term? Can you guess? It will be like 100 plus 16n only, right? Now anyway, I just recollect that idea here. Here what we will do is that, as you can see, as we move, there's an increase of 60 rupees in every kilometer, right? So what is happening actually? The cost of the function increases by 60 rupees every kilometer, right? Since it is a linearly increasing like this is an example of linear growth. As you can simply say, the value is increasing with every kilometer, so you can see that it's a growth only. If you draw the graph also, it will be like growing like this, increasing only, right? So going to the definition, we can see as the value of d increases by 1 kilometer, the value of cost function c also increases by a fixed amount 60. And this can be an example of linear growth. This kind of problem is an example of linear growth. Got the idea? As the number of the distance travel, our cost also increased. Okay, with one change in one variable, let the increase of the total value, it's known as a linear growth function. Okay, now moving to the next example, we will see what is linear decay. What is linear decay? Can you guess what will be linear decay? Linear growth means it is an increasing in the fixed amount, right? So linear decay will be decreasing in a fixed amount, isn't it? Okay, without wasting time, we will do an example. So example 10 says that the height of a water in cylindrical tank is 3 meter at the start of summer. So the height h meter at the end of t months is given by the linear function h of t is equal to 3 minus 0.5 t. So what does it actually indicate? 0.5 t means for every month t, 0.5 meter decrease is there in the total height of the water, right? So first of all, initially it's 3 meter. After 1 month, 0.5 meter decrease, that is 3 minus 0.5 into 1, that is 2.5. After 2 months, again minus 0.5, right? Again minus 0.5. So it will be 2. Again, third month, again there is a decrease of 0.5, that is 1.5. So in all this, you can see as the value of t increases by a fixed amount, the height decreases, right? I mean, as the t increases, month value increases 1, 2, 3, 4. As the months increases, the value total height of the water decreases with the fixed number only. What is the fixed number? It is 0.5 meter only, right? Now, this kind of examples represent linear decay. A fixed number is decreasing here, so this represent a linear decay. Last case, a fixed number was increasing, that's why it become linear growth. Got the idea? Okay, so yesterday we have done a question like reading a book every day. Some girls reading a book and every day she reads 20 pages, right? So is it a linear decay or linear growth? It will be a linear decay because every day she finishes 20 pages means first of all it was 500, then it was 480, then it was 460, like that. So a fixed amount is decreasing only, so it is a linear decay. Got the idea? Okay. Now we will start the exercise 4.2. Sorry, 2.4. Says that the first question says that suppose a plant height is 1.5 feet, 75 feet, and it grows by 0.5 feet each month. Find the length after 7 months. Second question, make a table of values for t varies from 0 to 10 months and show how the height h increases every month. Next question, find an expression that relate h and t. Explain why it is represent linear growth. So let us do one by one each of this question. Okay. So you know that the initial height is how much? 1.75 feet, right? And it grows by 0.5 feet, right? So first month how much it will be like? First month it will be like 1.75 plus 0.5 into 1 only, right? So 1.75 into 0.5 you will get 2.25 feet, right? How will it be in second month? Second month it will be like initially it was 1.75 plus 2 months means 0.5 into 2, or otherwise you can add 2.25 plus 0.5 also. Okay, so anyway this is will be like 1.75 plus 1, you will get it as 2.75, isn't it? If it goes like this, we have to find the value after 7 months, right? So height after 7 months is equal to, how we can find, it will be like 1.75, that is the initial height plus 0.5 into 7. Okay, so that is 1.75 plus 0.5 into 7, you will get it as 3.5. Okay, so 1 plus 3 you will get 4, 7.75 and 0.5 you will come to total 1.25, that is so you will get it as 3 totally you will get it as 5.25. Okay, total value will be 5.25 like this, 1.75 plus 3.5. Okay, so this will be 5, 7 plus 5 will be 12, remainder 1, so 5.25. Okay, otherwise you can do the mental calculation. 3 plus 1 will be 4, 7, 5 plus 5 will be 1.25. So that 4 plus 1, 5 and 5.25. Okay, so anyway after 7 months you will get it as 5.25 feet. Got the idea? Okay, now we will move to the second part of the question. Okay, so the second part actually says that you have to make a table of values for t varies from 0 to 10 months and show the height h increases every month. Okay, so we have done this first month, second month, like that you have to do up to 10 months. So and after that you have to make it in a table. This is actually very simple exercise only. Okay, so I have already done this. Like this you can see height of the first month will be 2.25 meter. Initially it was 1.75. After first month means 1.75 plus 1 into 0.5, that is 2.25. And like that I have done up to the 10 months. So it is will be 10 months, it will be 6.75 feet. Okay, and you have to represent in table means on first column you can represent time in months. Second column you can write the total height after that particular month. Okay, so you can do like this. Now the third question is like that you have to represent the linear expression. So this we have learned in the last exercise, okay, only. So if it was like end the month, okay, if it is like end the month, how we will represent? We will represent 1.75 plus 0.5 into n only, right? That is 1.75 plus 0.5 n only, right? So this will be a linear expression. Now what can you say about this from the table? What can you say? Is it is a linear growth or linear decay? As the month increases, a fixed amount of 0.5 feet is increasing, right? So we can clearly say that it is a linear growth only. Okay, so that's why express since starting with a height h and 1.7 starting with a height of 1.75 and adds 0.5 every month, we can express height h of t as 1.75 plus 0.5 t. Okay. Now, this represents a linear growth because as the height increases by a constant amount over interval of time, we can clearly say that it is a linear growth. Got it? So this is how we are doing all this exercise in this part. We will check whether it is a linear growth or linear decay, and we will represent it in the linear equation, and we will proceed. Okay, I hope it's clear for you. Now we can move to the second question. So the second question states that a mobile phone bought for 10,000 and its value decreases by 800 every year. Find the value of the phone after 3 years. Make a table values for t varies from 0 to 8 years and show how the value of the phone will depreciate with time. Find an expression that relates v and t and explain why it was representing a linear decay. Okay, so as you clearly it's visible it's linear decay only because at every year it will be decrease an amount of 8 rupees 800. So it will be decreasing only, it will be linear decay. Now we will represent this in mathematically. Okay, so we can write initial amount is equal to rupees 10,000, isn't it? Now value after 1 year. Value after 1 year means 800 rupees is decreasing. So 1000 minus 800. Since it is 1 year, 1 into 800 only. So you will get it as 9,200 rupees. Right. Now value after 2 year. Isn't it? Value after 2 year means 10,000 minus 2 into 800, or you can do 9,200 minus 800 also. So what will be it? You will get it as 8,400. What is our question? Our question is the value after 3 years. So value after 3 years means we have to subtract 3 into 800 from 10,000, right? So value after 3 years is equal to 10,000 minus 3 into 800, right? So while subtracting 10,000 minus 3 into 1,000 means 10,000 minus 2,400, right? So you will get it as 7,600. So you got it at value after 2 year will be 7,600. Got the idea? Okay. Now we will check what is the second part of the question. Like last question, you have to make a table of value t varying from 0 to 8 years and show how the value of the phone we depreciate with them. Okay. So we have done the first initially it will be 10,000, second year it will be 9,200, third year, second year it will be 8,400, third year it will be like 7,600. So as we goes like this, we can make a value like this, right? So fourth year it will be like 10,000 minus 800 into 4, you will get that 6,800. Like that up to the 8 year means it will be like 10,000 minus 800 into 8. That is 10,000 minus 6,400, you will get 3,600. So here we made a table that shows the values varies how the value of the phone depreciate with the years. We have made a table like that. Got the idea? Now last case, if I making the nth, or if you are making the linear equation value of the phone as v of t, how we can represent? I can represent is 10,000 minus 800 into t. If I am taking as t as the time means it will be 10,000 minus 800 t. Got the idea? So as the time increases or as the years goes on, the value of the phone decreases clearly by a constant value 800. So you can clearly say that it is a example of linear decay. Okay, that's what is given here. Value of 10,000 value of the phone starts as 10,000 and we have subtracting 800 every year. So the expression v of t will be 1,000 minus 800 t. So This is clearly linear decay because why? It decreases a constant amount 800 every time. Okay. Now we have two more questions. So we will move to the second last question. Okay. So the third question represents the initial population of a village is 750. Every year 50 people move from nearby city to the village. Find the population of the village after 6 years. Make a table of value for t varies from 0 to 10 years and show how population p increases every year. Find the expression that relates p and t and explain why it is represented linear growth. All these questions are same kind of questions only. Okay, so you know people are moving from city to the village. So initial population of the village. Initial population of village was how much? Yes, it was 750, right? So 750. So every year 50 people move from near, nearby city to the village. So population after 1 year means how will it work? After 1 year means it will be every year it will be 50 people moving. So 750 plus 1 into 50, that is where you will get finally 800 after how much? After 1 year. We have to find it after 6 years. So how will it work? Population after 6 year will be 750 plus 6 into 50, isn't it? So it will be like 750 plus 300, you will get that 1050. So by the 6th year, there will be 1050 people in that village. Okay. Now, second question says that we have to make the values for t varying from 0 to 10 years and show how the population p increases with every year. Okay. So like last question, we have to make a table for this. Okay. So moving into the second question, here we have the list of populations list from first year to last 10 years, coming 10 years. And okay, we have done a table accordingly. Initially it was 750, next year 50 people joined, so it will be first year it will be 800, second year it will be 850, and in the 10th year it will be 1250. Okay, so like last cases, if we look at the nth year, if we are looking for the nth year population, how we can write? We can write it as 750 plus n into 50 only, right? That is 750 plus 15n. So in each case, a constant value of 50 or 50 people is adding on every year, which means this is a linear growth because a constant value 50 is added to every year. Okay, so here we conclude once again. Population if representing is p of t means at the end the year or as the time varies, we can represent in the polynomial form. P of t is equal to 750 plus 15t. This is a linear growth because it is the population increases by a constant amount 50 people in every year. Got the idea? Okay. Now we will move to the last question of this one. A telecom company charges 600 for certain recharge scheme. This prepaid balance is reduced by 50 each day after the recharge. First of all, write an equation that models the remaining balance b of x after using the scheme for x days. Explain why it represents linear decay. Second question, after how many days will the balance run out? It's a nice question, not like the last cases you have to draw a table. Okay, so we will discuss that thoroughly. Third one, make a table of values for x varies from 1 to 10 days and show how the balance b of x reduces with time. Okay, so we will do the question like one by one. So considering the first question, we have to find the equation that model the remaining balance b of x after using the scheme for x days, right? So we will write initial amount as 600, right? Initial amount is 600 only. So balance after 1 day, how much amount will be reduced after 1 day? It will be 600 minus 1 into 15 only, right? That is 600 minus 15, you will get 585. Now balance after 2 day means it will be like 600 minus 2 into 15, that will be 570. Right. Now, if it goes like that, and if we take the number of days as x, and our polynomial equation after x ds, b of x can be represented as 600 minus 15x. Isn't it? After x days means we can represent b of x is equal to 600 minus 15x. Okay. Now, what can we say about it? Is it linear decay or linear growth? It's clearly visible that it's a linear decay only because every day 50 rupees is decreasing only, isn't it? So, we can say that if you represent the equation is as a 600 minus 15x, this represent a linear decay because the balance decreases by a constant amount 50. Okay. Now we will move to the second question. It's a nice question. After how many days will the balance run out? After how many days the balance run out? We know that our equation is like b of x is equal to 600 minus 15x. So if the balance run out means this b of x represent the balance after x days, right? And if it run out means the b of x should be 0, right? The balance should be 0. So what we have to do? We have to equate this equation into the 0, right? We have to consider b of x is equal to 0, right? So second question, equate b of x is equal to what? 0. Because if balance run out means 0 balance only. That means we know that 600 minus 15x is equal to 0. That is, we will get 600 is equal to 15x. So that x is equal to 600 by 15. 600 by 15 you will get it as 40. Right? So we can conclude that after 40 days the balance run out. Okay, because balance run out means the total amount the b of x should be 0 and we get the question to 0 and we got the x. The number of days means 40. X was our number of days. So after 40 days the balance will run out. Okay, now our third question is like that. Make a table using the value for x varies from 0 to 10 days and show how the balance b of x reduces with that. So like last questions only. So we have made it. Balance in the initial balance was 600. So first day it was 585. Second day it will be 570. Third day 600 minus 15 into 3, that is 600 minus 45, 555. And if it goes like that, after 10 day it will be 600 minus 15 into 10, that is 600 minus 150, you will get it as 450. And we made the table accordingly. Okay, it's a linear decay also since a constant value 50 decreases in each cases. Clear? So by here this question we have finished the whole questions of the 2.4 and I hope it's very clear for you. Okay, now by the next topic we will see in the next class. Till then, bye.